Hi everyone, I am Mega Baby. Today I am going to present the topic comparison of open addressing and chaining for a hash map in a banking system. In modern banking system, huge amounts of customer data are handled every second. To store and retrieve this data efficiently, banks widely use hash maps. However, while using hash maps, a major problem called hash collision occurs. Banks use hash maps to store and quickly access information such as account numbers, customer IDs, transaction reference numbers. These values act as keys and the associated customer detail act as values. Since banks manage millions of customer accounts, fast access is extremely important for balance checks, money transfers, online transactions. Because the data size is very large, hash collisions are unavoidable. Hence, efficient collision handling methods are required to maintain high performance. A hash collision occurs when two different keys generate the same index in a hash table. For example, if two account numbers produce the same hash value, they both try to occupy the same location in the table. To solve this problem, collision handling techniques are used. Two most commonly used techniques are open addressing and chaining. Let us consider a real-world banking system. A bank have millions of customers, and every time a customer checks their balance or makes a transaction, the system must find their account record very quickly. Because of the large amount of data, collisions are unavoidable. So, the banking system requires an efficient data structure and algorithm to handle these collisions without affecting performance. Simple data structures like arrays or lists are too slow for large-scale banking data. Hash maps are preferred because they provide fast search and insertion, and they work efficiently with a large data set, but the performance of a hash map depends on how collisions are handled. That is why we analyze collision handling algorithms such as open addressing and chaining. In open addressing, all records are stored directly inside the hash table itself. When a collision occurs, the system searches for another empty slot in the table. No extra data structure is used. And there are common probing techniques include linear probing, quadratic probing, and double hashing. Here, the table size is 7, so the index values range from 0 to 6. We use the hash function index equals key modulus 7. First, we insert the value 76. 76 modulus 7 gives 6. Since index 6 is empty, 76 is placed at index 6. Next, we insert 93. 93 modulus 7 gives 2. Index 2 is empty, so 93 is inserted there. Now we insert 40. 40 modulus 7 equals 5. Index 5 is empty, so 40 is placed at index 5. Next we insert 47. 47 modulus 7 also gives 5. But index 5 is already occupied by 40, so a collision occurs. To resolve this collision, linear probing is used. We check the next index, which is index 6, but it is already occupied. We then move to index 0, which is empty. So 47 is inserted at index 0. Now we insert 10. 10 modulus 7 equals 3. Index 3 is empty, so 10 is placed there. Finally, we insert 55. 55 modulus 7 equals 6. Index 6 is occupied, so we move to index 0, which is also occupied. Then we move to index 1, which is empty, so 55 is inserted at index 1. This completes the insertion process. Here are the algorithm steps for open addressing. Compute the hash index using the formula index equal to account number modulus table size. If the index is empty, insert the record. And if a collision occurs, check the next index, that is index plus 1 modulus table size. Repeat until an empty slot is found. Insert the record in that position. Now let us understand the pseudocode for open addressing using linear probing. First, we take the key and the value to be inserted into the hash table. We calculate the hash index using the formula index equals key modulus table size. Next, we check whether the calculated index is empty. If the index is not empty, it means a collision has occurred. So we move to the next index by adding 1 to the current index. And we apply modulus with the table size to stay within the table range. We repeat this process until an empty slot is found. Once an empty slot is found, we insert the value at that index in the hash table. This is how open addressing with linear probing handles collisions. The other technique is chaining. Chaining is a method used in hash tables to handle collisions. In chaining, each index of the hash table contains its own linked list. So, if multiple keys happen to map to the same index, all of them are stored together in the linked list at that position. One of the advantages of chaining is that the hash table never becomes completely full, since each index can grow dynamically through its linked list. Now let us understand chaining. Which one of the collision handling techniques used in hash maps, especially in banking systems? Here at the top we can see a hash table with different index positions such as 0, 1, 2 and 3. Each index represents a location where customer accounts records can be stored. Let us assume that multiple bank account numbers like 101, 112 and 123 all generate the same hash value which is index 3. This situation is called a hash collision because different key maps to the same index. In chaining, instead of searching for another empty slot, we store all the colliding elements at the same index using a linked list. So at index 3, we create a linked list. As shown in the image, index 3 points to the first node containing account number 101. This node then points to the next node 112 and finally to 123. Each box represents a bank account record and the arrow shows the link between records. When a new account number hashes to index 3, it is simply added to the linked list. There is no need to search for another index. Then the algorithm steps for chaining is compute the hash index, go to that index in the hash table. If the index is empty, create a new linked list. Insert the record into the linked list and multiple records can exist at the same index. Here we have a simple function to insert a value into a hash table. First, we calculate the index by taking the key modulus the table size. This ensures the key is mapped to a valid position in our hash table. Next, we append the value to the list at that index. Using a list allows us to handle collision by storing multiple values in the same slot. So every time we insert a key value pair, the hash function decides the slot and the function is added to the list at that position. This is a basic example of chaining in hash tables. In time complexity analysis, for both open addressing and chaining, best case time complexity is order of 1 and average case is order of 1. Worst case can be order of n when collision increase. This shows why collision handling is critical. In space complexity analysis, open addressing uses order of n space because everything is stored in the table itself. Chaining uses order of n plus m space where extra memory is needed for linked list nodes. Hash maps play a major role in banking systems, helping us to store and access data efficiently. Collisions are inevitable, so choosing the right strategy is important. Open addressing offers speed and memory efficiency, making it ideal for systems with limited space. Chaining, on the other hand, provides flexibility, scalability, and a safer way to handle collisions. Ultimately, the choice between open addressing and chaining depends on the specific requirements of the system. Thank you.